Right, off we go with the downward part of the flight. The ball is going to drop now to just 0.3 meters above the ground, where the batsman is caught out. We've got an initial velocity now at the top here, which is 0. Up is still positive, which means that g, of course, going downwards is going to be negative. So we know that the rising time from the previous calculation is 2,75. Was it 6 seconds? So now we want falling time, which we're going to then, we want both together, so we're going to add them up in a moment. So if delta y equals vi plus half gt squared, that's with the initial velocity equal to 0, then we start to substitute into here. And now you've got to think carefully, how big is delta y? In other words, how far is it from the top there to this point here? How far is that distance? So we need to take our previous answer, which was 38.59. Delta y is equal to 38,59. Subtract the 0,3, because it's always, that 38.59 was height above ground. So it's actually going to be 38,29 meters that we're going to use here. And then 38, if I substitute that in, now if I take that and substitute it in, it's going to equal half minus 9,8 delta t squared. So therefore, delta t squared is going to be 38,29 times 2 over minus 9,8. And if we just screech out 2 and take the square root on both sides, then we eventually end up with 2,80 seconds. Quite importantly, I think something we missed here was that this is negative, and therefore that is negative. Otherwise you end up taking the square root of a negative number, which wouldn't work. Okay, so therefore total t is equal to 2,76 plus 2,80, which is 5.56 seconds. Right, 5.5, nice simple equation of motion to wrap this up now. We've got we want a final velocity when it hits the hand of the fielder. We're going to take the very initial velocity for the whole flight and the total delta t for the whole flight. So it starts off at 27. Gravity is negative. The whole flight is 5.56 seconds long, and it's minus 27,4 meters per second, i.e. 27,4 meters per second. We're going to add that because we want 2 decimal places, meters per second downwards. So notice that this value is slightly higher than the initial velocity because the ball is slightly lower. If you're very brave, you can do the flight as a whole, and you can work out delta t using a quadratic equation, but that's only for the very brave among us.